Hello and welcome to our webinar on MMA proven applications, everyone. Thanks for joining us. I'm Louise Scott, Global Marketing Manager for IPS Adhesives. And today for our presentation, we'll have Melissa Thorelle, who's Technical Sales Support Specialist, and Andy Pace, European Sales Director. The presentation will last 25 minutes, and afterwards we'll have question and answers for another 5 minutes. Just to let you know, the session's going to be recorded, and we might as well just get set off now and hand over to Melissa.
Okay, so hello everyone, and let's get started with some basics. So what is an adhesive? So the definition is an adhesive is a non-metallic substance that is able to join two substrates together via two different mechanisms. The first one is adhesion. So it's represented on the image on the right by the red arrow, which represents the connection between the adhesive and the substrate, and it involves mainly physical interaction. The second mechanism is called cohesion, and it represents the internal strength of the adhesive, which are mainly involving some chemical force. So adhesives are usually single or dual component and are classified based on their chemistry. That's why you have epoxy, you have polyurethane, and you have MMA. MMA stands for methyl methacrylate. MMA are two-part acrylate, and it's composed of two different parts. So the first one is the adhesive, where you will find the MMA monomer, so the methyl methacrylate, but also the amine and some additive like rubber or toughening agent. All these additives are inside the formula to give the final property. So meaning if you want to improve the flexibility of the adhesive, if you want to improve the impact resistance, you will add all these additives to give the final properties of the material. And the second part is called the activator, and it's mainly composed of the peroxide. So when the two parts are mixed together, there is a reaction which is occurring, and the reaction will create an exothermic reaction. So you will have heat that will be generated. All the reaction is done at room temperature, so meaning that you don't need heat or external source like UV to have the curing. Everything is done at room temperature. And once the curing starts, so you will have an exothermic reaction, so temperature will increase. And when you reach the exothermic peak, you will reach the first mechanical properties of the adhesive, which is also called fixture time. MMA, so methyl methacrylate, is usually available in two different mixing ratios. So most of the time you have 1:1 and 10:1. The 1:1 tends to have higher strength and slightly lower flexibility, while the 10:1 have higher flexibility. When I say higher strength for the 1:1, it's usually lab shear strength above 20 MPa, while with the 10:1, you are usually above 15 MPa. And MMA has a quite wide service temperature from -50 up to 100 degrees C. So now let's review some advantages of MMA, but adhesive in general, over traditional joining methods such as rivet or bolting or welding. So when you apply an adhesive, you apply the adhesive on the wall contour, meaning that you will have a stress that is distributed on the wall area, on the wall contour, while when you have a rivet or a bolt, all the stress is concentrated at one location. So by using an adhesive or an MMA, you can improve the long-term durability of your assembly. Also, you don't need to drill, or you are not damaging the substrate by using an adhesive. You can also bring additional property. So for example, when you use an adhesive, you are not only bonding, but you are also sealing. So you can also improve the corrosion resistance. You can also improve the comfort by reducing and damping the noise and the vibration. You can improve also the aesthetic because you don't need to see the fastener, you don't see them, you don't have any welding mark. So in general, the aesthetic is improved. And one of the best advantage with adhesive in MMA in general is to have lightweight structure. When you are using an MMA, you can use different materials. So you can bond composite, you can bond plastic, you can bond all different kinds of substrate, and you can use also lightweight substrate like composite, sandwich. You can also use aluminum, but thinner. So all this combination is possible thanks to adhesive and especially MMA. So when we discuss and when we talk about structural adhesives, there are different kinds of adhesive. So as I mentioned, they are classified mainly by their chemistry. So on the market, and today I will focus only on epoxy, on MMA and polyurethane. So all room temperature curing adhesive only. So epoxy is represented here on the graph with the load and the displacement by the first curve where you have the highest slope. So an epoxy is well known on the market for their very high strength, but in the meantime, they can be quite brittle. That's what is represented here with a load displacement curve. Epoxy is also well known for the very good capacity and excellent weathering and temperature resistance up to 200 degrees C. So when you need an adhesive where the temperature in service is very high, above 200 degrees C, usually you go for an epoxy. But in the meantime, you have also some drawback. The curing, it's much slower compared to an MMA. Usually you need few hours up to few days, and sometimes you even need a post-curing to have the full properties of the epoxy. And also the adhesion on some substrate, usually you need some surface preparation to achieve good performance. Polyurethane is represented here by this curve, and he's lower in terms of strength compared to epoxy and MMA, but he has a higher elongation. This is why you have here a different slope. And polyurethane is well suited for application where you have high dynamic load, impact resistance, but the strength is lower. You have also other drawback with polyurethane regarding adhesion. It has very good adhesion to wood, to some polymers, but most of the time you need also an extensive surface preparation to have good properties. It's also quite sensitive to UV, and in terms of curing, much slower compared to MMA. So MMA is in between epoxy and polyurethane, and it combines the strength, but also the flexibility. So if we look at the benefit of MMA, so the first one is a complete room temperature curing material. So you don't need heating or post-curing to achieve a full conversion. It has also very good adhesion to composite, to metal, to plastic, and it can bond both of them and dissimilar material with a high flexibility, which is make him very suitable for application with dissimilar material where you need high impact resistance. MMA adhesive can be also adapted to your process. So if you need materials that is flowing quite easily, you can have this formula. But if you need something that needs to be applied vertically, even upside down with no sagging, you can also have a formula with a high thixotropy, so suited for vertical application. As I mentioned, you can have also very good impact resistance and high peel capabilities up to 15 Newton per millimeter with such adhesive. Sorry. No, I thought there was a question, but no. Sorry. So as I mentioned, so it's a very versatile technology that is being used in many different markets, and it's a technology that is known now for more than 20 years or even 30 years. And since a couple of years, we see a new product coming on the market based on acrylate. So in acrylate adhesive, you have MMA, methyl methacrylate, but you can have also different monomer. And this is what we are seeing also more and more on the market. So there are development of low odor formula and non-flammable classification. Everyone who has ever used an MMA knows that even a small droplet and you will smell this odor. And for some area or some factory, the odor can be a disadvantage and they are not allowed to use it, or worker mainly doesn't want to use it. That's why having new monomers, new development for low odor could be helpful. Also, MMA is classified as flammable, so a non-flammable classification can also improve storage and transport condition. Yeah, there are also new adhesive for bonding and nylon, and also LSE. So LSE stands for low surface energy. So when you take a low surface energy, like polypropylene, the surface tension is very low. So when you apply your adhesive, you don't have a good wetting, a good bonding. And there are new developments that allow adhesive to have good, so MMA acrylate adhesive to have good connection on this low surface energy without the use of a plasma or flame treatment. So it can reduce cost and also improve the production time. There are also new developments for galvanized steel bonding. Usually, to bond on galvanized steel, you need a primer before application or other surface preparation. There are new developments ongoing where MMA can bond directly galvanized steel without a primer. And there are also new products to improve the temperature resistance. As I mentioned, usually when you need a high temperature resistance, you go for an epoxy. But now we are also developing new MMA product or new adhesive that can have a better temperature resistance. So for example, in our range with an IPS, we have an adhesive that it's called AG800. And this material has a temperature service up to 150 and short term up to 200 degree F5. And this is made to be suitable for paint bake cycles. So all these combinations, the good, the fast curing, the fast handling strength, the adhesion on the metal, composite, plastic, without surface preparation, all these features make MMA used in many different markets, made in different industries. And now I will let Andy present some application in market where MMA are well suited.
Thank you, Melissa. So what I'd like to do in this little section is talk about the applications, some ideas of where all that great top technology that Melissa's just been talking about can be used. I think it's important to note that regardless of the markets, whether it's marine, building construction, transport, subsea, sign display, the majority of the substrates are the same. So if you bear that in mind when you look at applications, focus on the substrate first, and then the applications will come. I think sometimes it's we get stuck in we have to be in this market, and I think for me it's the market is the substrate and the rest will follow. So Melissa, next slide please. So marine, I won't go through all these applications, but we have a plethora of products that are used in the marine market. They all bring different values and properties to the marine industry. We have structural throughout. We also have the low surface energy that Melissa mentioned, and we also have now a SG2000, which is a two component one-to-one adhesive designed for large parts and large beads of material. So something that has been launched in the States and will slowly come over to the UK and Europe, and definitely will be of interest in the marine industry. So as you can see, bulkhead, stringers, flooring, console assemblies, the list goes on. But all these products bring different properties to this application, and we believe that we've got a nice portfolio of products that will really help the marine industry as they look to develop and grow their technology and their capabilities in building boats. Next, thank you. So a couple of things to highlight. We now have, well, we've had for many years, products that give you up to 80 mil bead size, which when you're building large structures such as hulls, you need that capability to give you bond as well as gap fill. These are great products that have minimal sag and give you a bondability to multiple surfaces. The other thing to consider is that they do have impact and fatigue resistance, which in marine is important. And we also have the chemistry that allows you to have quicker fixture time or slower fixture time, depending on the size of the substrate that you're bonding. So there's lots of flexibility in the systems that we offer. Okay. So using the same principles, if you move into rail, we do have, as we do with marine and rail approvals for our products, which will easily make it accessible to the rail companies and the marine companies. We get a lot of people asking for certain approvals. We found that opens doors, and so we now have those in place, which should make life easier when you're looking at using our products and designing or selling. So again, similar products, same sorts of substrates, but targeting different applications and different requirements within the structure. But fundamentally bonding plastics, metals, composites, FRP, GRP, etc. together, where our products really perform well. If you move on to the bus application, you'll see again, very similar to the rail, body panels, interior parts, window frames, and the list goes on. So for us, we live heavily in these markets. We're very successful in these markets, and we like to develop products to really allow the bus makers and the train makers to help them take out weight from the substrates that they're bonding. So a couple of things on this slide to consider. We have a number of customers that like to test our products, as everybody does, and we welcome that. The picture on the right, you'll see, if you can see, there's a crane attached to some aluminium substrate that has been bonded to a panel. And in that test, they were just doing a very basic pull test. Eventually the adhesive did give way, but it was actually the substrate that failed, which caused the two components to come apart. So great versatility. We've got vertical sag, which when you're working above or offering parts up that need to be bonded above you, this gives you a great extra benefit that the adhesive is not going to fall on you. We've also got minimal preparation, so a lot of the time we don't need primers to bond metals together. Other products do, and we're very good at bonding dissimilar substrates, which gives designers flexibility of what they can use and the best substrates for the application. We also offer, as I've mentioned, fast curing and slow curing components that give you flexibility in your production line, so that you're not fighting the clock on the adhesive itself. Okay. Another great application is composite tank bonding. This is a great market for us. We got into this many years ago. This was brought to our attention when they were trying to take the weight out of the tanks. They did a destruction test on a composite tank that was bonded together with our adhesive, and what we found was that the adhesive and the composite tank absorbed the crash and absorbed the shocks of destruction much better than the metal tanks. And so as a result of the testing, this has now become standard practice for bonding composite tanks. This is a great little application for bonding metal brackets onto car seats in the motorsport industry. But the reason why we highlighted this is because the SG5000 that's used in this application has got some flexibility in the substrates it can bond. It's a toughened adhesive, which gives great combination of rigid components and flexible components, allows the two substrates to bond and be successful in the application. Okay, so moving on to construction. Again, same principle, same substrates. We get involved in all sorts of new areas now in the construction vehicle market as vehicles become more diverse and they want more opportunities to use the same vehicle for multiple jobs, but they also want to take the weight out as well as ease of construction. So there's a lot of components now that are bonded, and we again have products that are approved by many of the large manufacturers, so that when it comes to designing, it's a much quicker process of getting the parts developed. And as you can see, we cover all aspects of the vehicle. Yep, move on. Yep. And then spinning on from that, some of the attachments that go on to tractors and diggers. We're also involved in bringing those elements together with bonding some of the side panels and roofs using our product. That they use it because it's a great application. A lot of the adhesive stays where you put it. You need minimal surface preparation. We get limited shrinkage and fast cure time, which gives them great pull through for the parts in their production. Leaves less parts in WIP, more parts going out the door to their customer. Okay, so a very brief overview of some of the applications. Feel free to download the video and have a look at some of the slides in more detail. But bear in mind, all the substrates are generally the same in most markets. And so I'd like to think we've got some solutions for you and your customers when they come to look at adhesives. So I'll open up the floor if there's any questions. Louise, anything posted?
There's nothing posted yet. We'll give a minute or so, see if any more just come through now.
No problem. What I would say is if you do have any questions, feel free to reach out, send us an email, drop us a note. More than happy to answer your questions offline. And if you've got any feedback, we'd love to get your feedback. If there's anything else you'd like to know, then please let us know, and we'll be more than happy to get back to you.
Yeah, there doesn't seem many questions out at the minute. I'm sure people will come up with some questions later on. Yeah, like Andy says, you can drop them in, you know, the website, the SCIGRIP website has a contact us page. Great if you can go on there. And just to say, really to conclude, thank you to Melissa and Andy for sharing the insights from today. And thank you all for coming and attending. It's great that you've joined us here today, and it's such a good attendance. We do have a resources page on our SCIGRIP website if you want to visit that for other information. And just to say thanks again, and we hope to see you again next time. Thanks for joining us.